The year is 2025. The famous detective Agent Hohms has retired at age 67 after solving a plethora of almost impossible cases. But just when he wants to take a break, he receives a phone call. The Interpol want him to investigate one final case before he retires. The team is hot on the trails of an international cybercriminal with his web spread all throughout the world. Their investigation has so far revealed that for five of the cases that Holmes previously solved, there was a hidden mastermind controlling the actions of the seeming perpetrators. This is the guy they want to catch. Holmes tells them that he's 67 years old, has a weak memory, and won't be able to process information as fast as he could earlier. But, says Interpol, you still have the same power of deduction that helped you solve all of those cases. What if we could provide you a solution, a chatbot, an assistant who can help you with all of the memory and retrieval related functions while you concentrate solely on deduction? Holmes agrees. Interpol then tasks Elisa, a generative AI engineer and a machine learning expert, to come up with this chatbot which will parse through all of Holmes' previously solved mysteries and help Holmes to rejig his memory and also help him with the analysis. I'm Raghav and I'm here to talk about the solution that was designed for Agent Hohms. This solution uses Gemini models in order to do the following. It has a few short system prompt which delineates its behavior. We are going to call this as Watson, and Watson is going to have a system prompt that tells it to be Holmes' assistant and use a few tools in order to augment its behavior. We'll get to that in a while. It's also going to use retrieval augmented generation in order to look at Holmes' previous histories, previous case histories, and whenever Holmes comes across any suspects, it's going to look through a citizen database in order to come up with matches. Finally, we are going to orchestrate this entire thing using LangGraph so Holmes can have a multi-turn conversation with Watson. So this is the aim of the chatbot. And we come to the system prompt, and the system prompt is fairly specific on the capabilities of Watson. It basically says that it can help with information retrieval, it can use tools for finding similarities among suspects using embeddings, as well as using retrieval augmented generation. So, those two are the tools it can use, and it should be aware of its limitations. It shouldn't hallucinate. There are also a couple of few short examples given in the system prompt itself. We then set up LangGraph in order to set this chatbot as a multi-turn conversation. After the usual inputs, we have an investigation state that talks about the messages that are going to be exchanged between the human and the chatbot nodes. The add messages here indicates that instead of replacing previous messages, the messages will get appended. There's a chatbot node which initially shows a welcome message, and after that, at each point, it's going to use the system prompt plus the current state of messages in order to take its next decision, in order to predict the next set of tokens. There's a human node which displays the last output from the chatbot and takes input from Holmes. This is the current rendering of how the Lang graph looks. And when Holmes initially gave it a try, it turned out to be a massive failure. The reason for that is, as you can see here, Holmes is asking, can you tell me about the case of the Raven? Actually, at this point, it has no information at all about any previous cases, but it says that if you give me a case number, I can take a look at it. But at each point, it's just trying to call a tool which doesn't exist, and it's basically just left Holmes in a limbo. So he's not happy with it, which is why we move on to the next step where we use a RAG to augment Watson's knowledge. As per Holmes and Elisa's request, we are now implementing a RAG to augment Watson's knowledge. We start off with a set of case files. So if you look at these case files, there's one where There's a backdoor. There's one where someone's adding a malicious code, and there's one where there's smuggling going on, another where there's smuggling of integrated circuits, and finally there's someone doing high frequency trading. All of these cases that Holmes has solved in the past, but all of these having a shadow connection. So initially, what we tried is to upload the entire case as a single file. But then when you do that, when you do a query, it's going to get back all of the cases. So we are going to have to chunk them. We are using a very basic chunking here where each of these cases is a separate file. And what we do here is read the files. Since the files are all prefixed with case and then they just have numerals, we are just iterating over 1 to 6 and reading all those files. We are appending it to a documents array. Once this is done, there comes the step of embeddings. Using embeddings to enable RAG. We are going to install ChromaDB. Once ChromaDB is installed, we are going to create a database called as the previous case database. And for this, we are going to use a class which is called as the Gemini embedding function. Basically, what's this going to do is it's going to work as both retrieval and query. It's going to provide both of those functionalities. And for that, we are not going to use the Flash models. We are going to use a model that is capable of doing text embeddings. So with this set and with our Google API key set and a database set, we are going to create a collection with this database name. Once this collection is created, all of the data from the previous cases is going to be loaded into this database. Scrolling down further, we now look at our LangGraph state with the RAG added as a tool. For this, we are going to get the collection first. So if you see, we have the database, we are creating a ChromaDB client and we are getting the collection. Once the collection is obtained, we are defining a new LangGraph tool called the retrieve documents tool. If you scroll up way above to the system prompt, you will see that we have already mentioned to Watson that you can use this tool for retrieving previous information. Coming back to the code, we define this tool, and within this tool, we are doing a query on the Chroma database, and we are saying, pick me the top 3 results based on whatever matches the query. Once this is done, we are going to add changes into the existing line graph. So the first change we are going to see here is an execute tools call. I'm not going to go into this in much detail, but basically, whenever you invoke a tool or whenever the LLM wants to invoke a tool, that results in an execute tools call. And we will in turn call the retrieve documents tool. How does it know to call the execute tools function? That is because we have our graph set up in such a way that whenever the LLM wants to do a tool call, it will call the execute tools end. And we are also adding conditional edges on the graph builder, saying that from the chatbot node, you can either go back to the human, which was the case earlier, or you can now go to the tool call as and when needed. With this set, we now allow Holmes to go and try this out. Hopefully, he likes it this time. So, when he was trying it out, he was asking about someone called Rosie, and the LLM was able to use RAG. So, if you can look at the output here, it was able to use the tool call to retrieve documents, and you can even ask it specific questions as to what was the crime, and it's able to extract the exact set of text that's required. So it's going to get this whole case file, but there's LLM magic on top, so it's going to extract the required information and give you just what you need. So Holmes is undeniably a little more happier now, but we are going to make him a little more happier in a bit. In the final section of this project, we are going to give Watson the ability to look at patterns. So basically, I could say, look for someone with blue eyes, black hair, this much height, and so on. And Watson is able to go look at a citizen database and generate a similarity score. This is quintessential when you want to narrow down your range of suspects. And we are hopeful that Holmes would like this as well, in addition to knowing about the previous cases. So to do this, we are going to use embeddings, and embeddings with a particular task type, which is the semantic similarity score. Let's see how this was implemented and then given to Elisa and finally to Holmes. We're going to look at the code now. A lot of the code is similar from previous. I've just included it here for completeness. And if you scroll way down, you can see that we are adding, in addition to the retrieve documents tool, which was there earlier, we are also adding a new function which requires semantic similarity. So we have changed the class, the Gemini embedding function class, a bit in order to take the task type as an argument. And now we are going to use this. So what we do is we've just, for the sake of completeness, we've just generated this set of citizen database values. And for example, this person is an entrepreneur and likes classical music, and this person is a curious teenager, and so on. So this could be a description of a lot of people. We have just kept it at 20 for now. And if you scroll down, you can see that we are generating embeddings off of this citizen database, which is the first step. And in the second step, we have introduced a new tool called the Search Citizen Database tool. This is going to be an additional step, an additional tool in our LangGraph kit. And what this tool does is it generates the embeddings of the suspect. So basically, Holmes could jump in and say, hey, look for someone with blue eyes, this much tall, etc. And that would be a suspect description. And we generate an embedding of that. We already have an embedding of the citizens database, of the citizen data. So we go and take both of these embeddings and calculate a similarity score based on cosine similarity. Once this is done, we sort the citizens based on the similarity score, and we pick the top three. We could have picked like the top four or top five. Just for the sake of this project, we are picking top three. And we also want to ensure that even though you have picked the top three, they shouldn't be someone who's completely unrelated to the suspect, which is why we have a threshold of the cosine similarity. So we have set the threshold at zero point 0.6, which is basically you're saying if there's a 60% match between the person I'm looking for and what you have in your database, send him to me. So with this, we mostly completed our code. In the end, we have just modified the system prompt a bit. So from being just a string, it has changed to a chat prompt template. And you can basically specify that this is a system prompt, just an additional thing. And if you scroll below, you can see that our execute tools has also changed. We now pass in the required tool and invoke that tool, as compared to directly invoking the documents retrieval tool earlier. And finally, in our LangGraph nodes, you'll see that we have the call tool, which has become generic. So this encompasses both the retrieve documents tool as well as the citizen search tool. And then we have the loop between Watson and the human, which is Holmes, and Watson and the tool. So this is a complete conversation at this point. We submitted this to Holmes with cross fingers. He did have a quick try. So he initially goes and asks about someone saying M. Du Bois from one of the cases. And he also goes and asks, can you look him up on the citizen database? So at this point, Watson is actually doing two tool calls. It's going to the previous case and picking up the specification or the characteristics of this person, Du Bois, and looking him up on the citizen database. And if you look at this, you can see that both of these tool calls are happening, and it has this specification. And finally, there's also the matches with a similarity score. But Holmes being Holmes, he comes back later to the tool with a very odd request. He says, look for a rich person who likes opera. Because according to him, according to his detective skills, this is the clincher. This is the clue that will help him land the suspect. And once we look for that, the Watson actually identifies that Roldan G has the highest similarity score and is possibly the hidden connection in all of these cases. Will Holmes be able to catch him? What happens next? We gotta stay tuned.